So welcome to my next lecture, consistency limits. So previously in index properties we have seen water content, specific gravity, density and field density, and the respective tests conducted at the laboratory as well as the field we can find the index properties. So as I have already given the introduction about index properties, I hope you have understand that what is index properties. So let me start with the next property, consistency limits. So consistency limits are the very major thing, so we have to understand it very thoroughly because it is playing major role in the engineering properties. So consistency limits, what is consistency? So what is consistency? In the sense it is just like a state, like a state. So for example, if you take a metal, so consider this is a metal. If you applying load, it has got deformed. So which means, so as you know, so all the metals or materials, like all the metals will have elastic state and plastic state. So say for this is an considering this is an steel metal. So if you are applying load, it is got deforming, and once you release the load, it is getting its original shape. This is known as elastic limit, elastic state. So within that elastic limit, so it will be playing an elastic state. It will be considered as an elastic material. So once it has got too much loaded, so the deformed shape cannot be gain its original shape. So that is what plastic state. So this is consistency limits. Consistency here refers that state of soil, which means the resistance to deformation. So there is an clay soil. If I'm applying load on it, so what happens as you apply load here, so it is going elastic and plastic, etc. But if you have an dry a lump of clay soil, so as you know, it is very like a solid thing. So if you are applying load, you cannot break the clay soil because it is very tough by the cohesion. So it is offering more resistance. So consistency is nothing but, it is in resistant to deformation is nothing but consistency. So now when it starts with this consistency limits, so any metal has elastic and plastic behaviors. So what soil can have, so this consistency, especially I'm going to talk about for cohesive soils, because for a sand there is no consistency limit. If you taking a sand in hand and you just compressing it, it is just in loose particles, and particle by particle it may offer load, it is just in solid state as we say. But in case of a clay, when it is initially dry, by adding water, now water is coming into picture, so it can travel into different state. So what are those states? Solid state, semi-solid state, plastic state, and liquid state. So solid state, semi-solid state, plastic state and liquid states are the four different states a soil can be. So this consistency limits is applicable for 425 micron fine grains soils, which should have cohesive in nature. Cohesive soils is only applicable. So in this four different states, I can explain with the plastic state clearly. So what is plastic state in soil? We have an pot. We are making a pot out of soil only. So while making this pot is nothing but plastic state. You are molding it. So which means you are molding the soil sample which gains the shape. So that is nothing but plastic. So as you see in China clay, it is in white clay. They are forming bowls. As they are eating a food through that bowl, so we have like pingans. So all those things are made up out of a white clay. So you are molding it. So what is mean by molding? Once you are molding, so it retains its shape. So that is nothing but plastic. Once you deforming it and again it gets original shape, that is elastic. So however, soil doesn't have that elastic state. So once you are trying to mold it, it gains its shape. That is what elastic state, plastic state. So this, what is playing role, what is giving that behavior, it is nothing but cohesion. So soil has a dry state, it has an particles, so completely binded with so completely binded with cohesive. So it is an so minus 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 plus and plus. So once you add water, it is gaining like this. So initially, so it will be attracted minus, so this minus is get attracted by this plus and this plus, so it will be like this. So this will be giving the resistance once you applied load. Once you add water, it is got filled. Now what happens if you apply load? So this water layers will like lubricant, will act like lubricant. So if you press this, so water particles, soil particles will be moving because water acting as an lubricant. And so like this I can explain. So initially it is like this. So once you add up applying load, it is got moving and it is occupying different places, but still it retains its cohesion. So that is why it will be as a whole. So like that, so it will be as like a whole. So that is why it got moving, and by still cohesion is there, that is why it's gaining its original shape. So it is nothing but in plastic state. What is about a liquid state? What is about liquid state in the sense, if you are adding more water, it again forms another layer. If you add more water, it also gaining on it. So initially it may be like this, but slowly it is turning into like this. Now we have a minus minus here and minus minus here. So this minus will act as an repulsive force, so resulting which, so this soil particles are completely getting repulsed, so there will be no cohesion further at all. So it will not be, so it will be like standing lubricantly like a water. So it is nothing but liquid state. So if you made a slope like this, and if you put this solid sample, so it may flow, so it gets liquid state because it loses its stability. So initially it has cohesion, because of that it gaining some shape, but now it is all the particles are losing its stability, so there is no cohesion, losing its stability. If you keep this in any slope, it may trying to flow. So that flow refers the liquid state. So at this state, if you placing your soil and just trying to just press it, so if now you are giving load, so it will be squeezing out of your fingers. So that is nothing but liquid state. So what about semi-solid state, or what about the solid state? So semi-solid state can be explained. You are adding water and you are trying to make a ball out of it, but you are not getting that ball, which means it doesn't reach the plastic state. So it doesn't reach this plastic state. So in that plastic state, certain moisture only it can gain the shape. Now it is not gaining the shape, which means it is a semi-solid state. Solid state, it is a very dry state, but it also has moisture content. So we have some other concepts to describe. So let me taking this in as a graph. So what happens? So this is water content and this is what volume. So as I have explained, so this is called a flocculent structure. So now say it is an 50 ml or 50 centimeter cube. It is a measuring jar. Once you add water, so up to solid state, so it is in volume, constant volume of water. So further addition of water will increases the volume keep on. In case of sand, if you add water, so soil will be acidus and water will be going above the solids. Now if you adding the water will improve the volume of the clay soil also, which means, so adding water, so it added, now so when all the pores are filled with water, so it is reaching this limit called shrinkage limit, and while then it is like an swelling, so which means waters are added, it is like swelling. And so after the shrinkage limit, while adding water, it is water volume of water is going down. So this is plastic limit and this is liquid limit. So liquid limit, plastic limit, shrinkage limit. What is liquid limit? So this is a particular moisture content, say it is a point, say at 35%, 35% at 35% of moisture content. So this soil, particular clay soil, is changing plastic state into liquid state, or liquid state into plastic state. At this moisture content it may vary, but this is vary with soil to soil. So it is clay soil 1 we get 35%, but different samples the value may differ. It may be 40% or it may be 20%, like that it may differ. It entirely depends on amount of clay present and minerals present. So what is plastic limit? So it is an limit, say 20% for example. So at this percentage it is about to change plastic state, or plastic state from semi-solid state, it is plastic limit. Shrinkage limit also can be described with the same, solid to semi-solid state or semi-solid to semi-solid state changing point is nothing but shrinkage limit. So now it can be also described as, so it is a moisture content at which further reduction in water will not cause any volume change. So here also it can be described here, this shrinkage, liquid limit, plastic limit and shrinkage limit, all these three limits are represented as fully saturated conditions. So fully saturated conditions, which means so all the pores are filled with water, shrinkage limit, plastic limit and liquid limit. So all the limits are filled with water. Now, so why do we want to find these limits? So it has some influences over behavior, which means we can find this amount of clay and so we have to understand this first thing, amount of clay and type of clay minerals is going to be playing role in this figure. So how to find this? For example, so plastic limit minus liquid limit minus plastic limit is nothing but plasticity index, which means starting from 20% to 35% it can be plastic. So it is an range or it is an index. So in this range starting from 20 to 35%, so you get 15%. So in this 15% of range, so this soil can be in plastic state. So at reaching 35% it can be going to be in liquid state. Say for example, there is another different soil at 50%, it is gained liquid state. What will be the value? So 50 minus 20, it is 30%. So clay sample 1 15%, clay sample 2 30%. What makes this difference? Which means all the cohesion value are neutralized by water, then only it reaches liquid limit. So which means if you need more water to reach liquid limit, which has either it should be an more amount of clay or it should the type of clay minerals playing role. So we have an different clay minerals, montmorillonite. So I will be giving this with a graph. So this is IP, this is percentage clay. So this is montmorillonite and this is bentonite, which means this is not very much active, but montmorillonite clay black color is very active. How? In the sense, say for example 30% of clay present, IP is very just lesser 20%. So 80% of clay present, IP is 30%, but this 20% of Montmorillonite clay can exhibit plasticity index of 30%. So if the Montmorillonite present just 20% by weight so it can exhibit 30%. The quantity is very less, but it is making too much influence because this cohesion is too high. So we have in different minerals, vermiculite, illite, chlorite, and bentonite, Montmorillonite, and kaolinite. So we have different minerals. Each will exhibit a different amount of forces. So this amount of forces and amount of clay present can influence everything. So this is the final thing I want to tell about it. Now we'll be discussing the lab test. So how to find liquid limit? How to find liquid limit? It is described by Casagrande. So all this liquid limit, plastic limit, and shrinkage limit are given by Atterberg. So Atterberg is an agri farmer who has given an idea about this consistency of clay. So he is an agri farmer only. So he has given the consistency limits. But now we are going to discuss liquid limit test, how to find liquid limit. So that is described by Casagrande. So what he is telling, we have to take a bowl. It is a bowl setup, and while giving rotation it will be going up and down. So we are taking in a china clay, take 100 grams of clay sample and adding it. And now, so in this graph, so we are going like this. So in this graph we are going like this. When water content added, it will be going and furtherly finally reach liquid limit test. In this test, so now 100 grams of soil, and you are adding known water, say 20 milligrams or 20 ml water is added and got mixed thoroughly, and you have to placing it here, and you are placing it here, and this is a lever arm setup. So while giving lever, so this will be growing, so in cross section, so it is going up and down. So there is a bed and setup. So while giving, so it is going up and down. So this is 1 cm height of fall. So what do we have to do? So there is a groove. So it will be a, so like this. So you have to groove this, and there is an two portion it got divided, and once you are rotating this, so it has to be, so this two portion got divided like this. So there is a gap. So this gap, so when you are giving impact, it is like coming closer, and at once it got touches because of this vibration. So once it is touches, it is making 1 cm length touching zone. So that if that happens at 25 blows, so if you are giving one rotation, that represents one blow. If this touching happens 25 blows, the respective moisture present in this soil sample is nothing but liquid limit. So it cannot be achieved at the first trial. So you have to do some lot of trial. So initially it may be 20 ml and respective blow is 50 blow. So again you added 22 ml and 2 ml addition, you get 40 blows joining, and 24 blows you get 30 value, at 26 blows you get 20 value. So you have to draw a graph with the help of this. So number of blows and water content added here. So it is a semi-log, graph, and you will be getting a curve like this. So W1, N1, N2, W2. So this is nothing but W2 minus W1 divided by log N1 minus log N2. W2 minus W1 divided by log of N1 divided by N2 is nothing but flow index. when flow index is higher, shear strength lesser. Flow index lesser, shear strength is higher. So this is, as I have told, this is an index property. So this index property indicate about shear strength is nothing but engineering property. So this is index property. So we'll talk about engineering property. Now second thing is plastic limit. So how to find this plastic limit? In the sense, you have to take 30 grams of dry soil, so adding water drop by drop. So in this case, previous case we have been gone through like this, but in this case, so this shrinkage limit, plastic limit and liquid limit will be coming like this to find this point. So how to find this point, sir? So which means 30 grams of sample you have taken, so 30 grams of soil sample taken in a bowl, and you are adding water, drop of water, and you are trying to make a ball out of it. You are going to make a ball out of it. So while adding water, so it has got while adding water you cannot make ball, so it is simply traveling through which, so once it is solid or semi-solid state, it will be like broken pieces. It won't get, you cannot make ball out of it. Once it crosses the plastic limit, you can make it ball, which may be in plastic state. Now add just 2 drops, so you, and make sure that you are about this level, and take a small piece of a soil sample here, and you will be given with an glass plate. So this small piece of a ball has to be rolled like this. So that is a small one, so it has to be rolled like this. So once you are rolling, it will be forming a thread like this. So this, while rolling, it will be forming a thread like this. So this has to be 3 mm in dia and length may be 10 cm, about which, so while rolling this you have to give pressure equally throughout the length, so it is threading. So once during this threading, so because of this body temperature, so the moisture present in this soil sample got releasing, so it is slowly got traveling towards like this. So once it attains this point, so there will be cracks developing. So it is losing to regain its plastic state, so it is start gaining some cracks. So this cracks represents it is already reaches the plastic limit. So now we doesn't know the moisture present and this threads. What we do some threads like this, and we taking a mass of it, say 10 grams or 12 grams, say let us keep 10 grams, and you are taking into a container and placing it and finding mass m1. So after 24 hours in hot air oven, 24 hours hot air oven, so you get the value of dry m2. So m1 minus m2, that is in mass of water, divided by m2 dry sample, you will get giving moisture content, that is nothing but plastic limit. So how to find shrinkage limit? So shrinkage limit, how to find this shrinkage limit? So how to find this shrinkage limit? It is a little bit of tedious test. So I can give you example like this. Very simple thing. So it is a dry pat. Let me come by one. So you are taking a steel pat like this, steel dish, you are taking a steel like this, and you are adding water in the soil sample, soil plus water you are adding, you are preparing this and completely filled this clay sample, and you are placing in an oven. So the next day, while taking, it is nothing but a dry pat, and this is inside the, so somehow the volume got shrinked. So as you see in agri field, So you can see the very cracked shape of soils. So it is nothing but the volume got shrink. So it is an initial volume V1. So it is an V2. This is V2 is an shrinked volume. So and V2 minus V1 is nothing but a gap. So V2 minus V1 is a gap. So as I have described, what is shrinkage limit? So at this limit, further reduction in water content will not cause any volume change. So now this volume cannot be going to be changed further, but at this exactly at the limit, so it may have some water inside. Now it is getting reduced, so we have to find what is the moisture which is occupied all this force. As I have explained, it is fully saturated. So what is the mass which is fully occupied this pores? So that is our task. Now m1 minus m2 will give you total mass of water. Now so this is a shrinkaged volume. So what is the water that can be occupied this shrinkaged volume? Once you minus this total volume minus this, you will be getting the respective mass of the water which is occupied in the pores. You get volume of in terms of volume, and multiplying with density of water, you will be getting mass, so which is occupied. So this total mass of water which is minus what is the mass of water which got occupied the gap. Once you minus, you get mass of water present in the pores. So divided by ms is nothing but dry sample. So you weigh this this red color dry part mass, you will be getting ms, so will be equal to this. So shrinkage limit is nothing but mass of water to the mass of dry soil. So there is a mass of water present in the pores. So with this three consistency limits, liquid limit, plastic limit and shrinkage limit, I hope you have understand the relative concepts and how to determine this in laboratory. So it is very simple as explained. So the major thing we'll talk about the consistency is nothing but the amount of clay present and type of the clay present can be described. Thank you.